Hello folks, we have come again for the next video for SICI. This is basically compound interest. And in case of compound interest, you need to understand, like we have already learned what is simple interest. We have done some questions, and this is we are doing all the arithmetic playlist. And if you have not joined our iQuanta channel, please join us. So we will provide all the arithmetic concepts in this playlist. And remember, this playlist is very important because arithmetic is arguably the most important section of quant section. Why I'm saying arguably? The reason is only thing, that is this year, like the previous year, 2023, we have almost same arithmetic and algebra questions. But except those years, the last 4 or 5 years, we have always abundance of arithmetic. Abundance, actually. Like there's so many questions, like 10 to 12 questions from arithmetic. But first thing you have to understand while doing all these kind of things, like exactly what is our perspective while doing this kind of videos. So I want you to learn everything whatever exactly is there in CAT, especially at least in arithmetic. And if you can do arithmetic, you can ace a lot of things with arithmetic, like all the other exams. Like it's not only about CAT, it's about CLAT, it's about let's say the IPMAT, it's about any exam like ZAT, like let's say not IFT is there, like this the other exams like NMAT. So everything, like it's a very dependent on arithmetic. So let's start with compound interest. So in case of compound interest, like the first thing we will start with, like what is compound interest? Like first, so you need to understand, like interest is something which actually is compensation. I have already told you. And simple interest is something which we generally do not use simple interest almost in anywhere, but we use compound interest. And compound interest is a miracle, because if something is compounded, compounding is basically an exponential kind of function. Simple interest is linear function. एक साल में 10, 1 year 10 rupees, 2 year 20 rupees, 3 year 30 rupees. It goes on like this. But in case of compound interest, it goes on like 100, 110, 121. So it goes on like this. You understand? So it is increasing. It's increasing how? Exponentially. So that is the importance of compound. That's why we generally always use compound interest, and that's why compound interest a little bit more complicated than simple interest. It's not as simple as simple interest, but it is also not very complicated if you understand it. So first I will give you one example how exactly we use compound interest and what is the factor of compound interest we are going to use here. The first thing you need to understand, like let's say the principal amount I'm defining the principal amount. Let's say this is 100. So 100 is the principal amount. So if the principal amount is 100, so first I'm writing principal amount. This is SI, this is principal amount, this is CI. And I'll show you how it is basically changing with years. And think about principal amount as 100 and the rate is 10%. In case of simple interest, it is just the interest. In case of compound interest, it's compounded annually, right? Annually, or what does annually means? I'll explain right now. So first year the principal amount is 100, obviously. This is this SI case. So the interest is 10 rupees. I have already discussed you. In case of principal amount for compound interest, first year is 100 and the interest is again 10. So it is 110, 110, as simple as this, right? Now think about it. Think about it in second year. In simple interest, the principal amount doesn't change. The principal amount is exactly 100. It has not changed at all. And the interest is also 10. The interest has not changed as well. This is, let's say, first year. This is second year. But in second year, this compound interest, as it is compounded annually, so after 1 year, this compound interest is added to principal amount. You understand me what I'm saying? The compound interest is added to what? The compound interest is added to principal amount. Now if the compound interest is added to principal amount, so I'm adding 10, so it will become 110. So you can see the principal amount is starting to change. In case of a simple interest, no change in principal amount. In case of compound interest, there is a change in principal amount. So what is 10% of 110? It is only 11, right? So 10% of 110 is 11. So we have got one thing from here. Next is for third year. For third year, if I write, this is 100, yes, this is 10. So there is no change in simple interest again, but in compound interest, this 11 will again add to this the principal amount, because principal amount is increasing after every year. That's why it is compounded annually. Clear? So now it is 121. So it becomes, now what is the 10% of 121? That is nothing but 12.1. That is the 10% of 121. Now what happens in fourth year also? Let's think about fourth year. This becomes 100 only. This is 100. This is 10. There is no change. But this is again adding to this. So it becomes 133.1. And what is the interest? 13.31. So you understand, like Rex, think about it. The interest is also changing and the principal amount is also changing. So everything is changing. But in case of simple interest, everything is same. Everything is same. So that's the difference between simple interest and compound interest. Somehow compound interest is changing much more rapidly, and this is exponential. And how it is exponential, that also we'll explain. Don't worry. So now if I ask you what is the interest for first year, the interest for first year is same as SI, which is 10. Interest for second, this is first year interest. This is second year interest. What is second year interest? 11. What is third? I'm not saying about 3 years. I'm saying about second, third, fourth. But if I'm saying what is the interest for 2 years? What is the interest for 2 years? The interest for 2 years is 10 plus 11, which is 21. Right? That is the interest for 2 years. What is the interest for 3 years? That is, add this 3 thing. That is 33.1. What is the interest for 4 years? Add 4 things, which is 46.41. So this way we can find the exact interest as well. This way we can find the amount as well. So if I can say the 4 years interest is 46.41, and after 4 years what is the principal? That is 146.41, because this thing is just adding it. So I hope you have understood like how exactly this kind of situation works. And remember one thing, it's a very important thing to remember, like whenever this kind of situation works, you have to understand exactly where we use simple interest, where we use compound interest. Until unless nothing is mentioned, we generally do not do compounding, we do simple interest. But in case of compound interest, we have to do compound interest. If it is not mentioned anything, we do it compound interest, compounded annually. If something is mentioned, we will discuss how we actually handle those things. Now the next thing, obviously, this is like the base of compound interest. I have already told you the basic of compound interest. The next thing is much more interesting. Now you have understood like this is 1021. I just removed something from here. I'm just removing the simple interest part, because simple interest you already know. So I'm just keeping it here. The rest thing I'm just erasing. Clear? Now in the rest thing, let me do something much more interesting. Now think about one thing. Think about very important thing. If I want to develop a formula for this, so the formula for principal amount, in case of simple interest we find directly the interest. In case of compound interest we find principal amount after n. Let's say this is P1 dash is same. This is, let's say, P2, principal amount after 2 years, principal amount after 1 year, principal amount after 2 years. So principal amount after n years. After n years is nothing but P into 1 plus R upon 100 to the power n. This is principal amount after n years. And what is compound interest? That is P into 1 plus R upon 100 to the power n minus P. That is compound interest straight away. Straight away this is compound interest. Now see whether we are succeeding in both ways, manually and this way it is same or not, we just need to check. So think about principal amount after 3 years. So what is it? P3. So P3 is, what is P? 100. What is 1? Plus R is what? 10 upon 100 to the power 3. So if you solve it, like 100 into 1.1 cube, 1.01 cube. So if you solve this thing, you will get 133.1. Right? So I'm sorry, this is 1.1. 10 upon 100, this is 1.1 cube. So if I add, do this thing, so we'll get 133.1. That's it. Now if I want to find principal amount after 2 years, so that is 100 into 1 plus 10 upon 100 square. So your answer is 121. Now if I need to find directly the compound interest, let's say I need to find directly the compound interest, then it is 121 minus 100, which is 21. So that is how, that is like P2 minus P, right? So this is like the way how we use the formula. So the formula is P into 1 plus R upon 100 to the power n. This is like Pn, like compound interest after nth, like principal amount after nth year. Which is it? This is principal amount after nth year, after nth year. Remember this clearly. Now how exactly we can do it in other ways? I have told you we can use successive also in this particular thing, right? Successive in this. Remember, successive in compound interest. Now how we can do it? Think about it like a 10%, right? So in 1 year, if you remember, 1 year the interest is 10, the 2 years the interest was 21, 3 year it is 33.1, and 4 year it is 46.41. That we have done in the previous slide only. Now think about it, how can I do it with the help of successive? So what is the formula for successive? If you remember, m plus n plus mn upon 100. Now 10 plus 10, first year 10, next year 10, plus 10 into 10 upon 100. How much it is? 21, right? 21 it is. Third year, you need to find 21 plus 10 plus 21 into 10 upon 100, which is 33.1. Now if you need to find for 4 years compound interest, so 2 years is 21, what is 4? 2 plus 2, what is 3? 2 plus 1, what is 1? What is 2? 1 plus 1, so what is 4? 2 plus 2. So what is the interest for 2 years? 21. So add 21 plus 21 plus 21 into 21 upon 100, which is nothing but 46.41. So this is how exactly we generally do this kind of things, right? We can use this particular concept as well. Now the very important thing from here also we need to understand, like how exactly we are going to use all these things in our questions as well. Now there is one example what I have already told you. I just summarize all of these things, like compound interest, like this is CI, this is, let me use another color of ink, let's say blue will be do. So compound interest CI, principal of sum is P, maturity amount they have said A, no problem. So R% is the per annum interest rate, time is T. So what is your amount A? That is P into 1 plus R upon 100 to the power T, which I have used N also, and A is P plus compound interest, and compound interest is A minus P, right? For N is 10% P, it is 10,000. So you can see for nth year it is total CA, that is 11th year. So for first year this is 11,000. For 2 we have done already for 100. So just remove 0, 0, 0, like, or you have a 0.1 and remove 0, 0, like 1, 0 either. So you can see like we get all of this kind of things directly, right? So 10, 11, 12.1, 13.31. So this is exactly what we have done already. So this is like the entire table format. And remember this thing also, compound interest for n plus 1th year upon compound interest for nth year is nothing but 1 plus R upon 100. It's nothing but 1 plus R upon 100. And this is also known as multiplication factor. So compound interest for n plus 1th year upon compound interest for nth year is always, remember how much? It is 1 plus R upon 100. 1 plus R upon 100, right? So how can I say this thing? So if you remember 21, right? And 10. So you can think, you can see all of these things directly with this also. So interest is like, if 2 years is 21, so let me change the color of the pen. So let me make it white. So if 2 year it is 21, 2 years, in the first year it is 10, the second year is 11, and first year is 10, right? So 10 into 1 plus 10 upon 100 is what? It's 11. So this is the formula. So the formula is compound interest for n plus 1th year upon compound interest for nth year is 1 plus R upon 100. Please remember it carefully. This is very useful formula, right? This is also known as the multiplying factor of this. Now after these things we need to understand certain basic things of compound interest, simple interest also. Let me discuss all these things first. Then we'll go for the next thing, like the basic major things in compound and simple interest, like together obviously. Now the first thing is, what is the difference? The difference between compound interest, if I'm not writing anything, that is compounded annually, and simple interest after 2 years. After 2 years, right? The answer is R square upon 100%, and if the principal amount is given, that is P R square upon 100 square. So this is in percentage, this is in amount. So the difference between compound interest and simple interest after 2 years is this. What was the example? Think about like the 100 and 10%, right? What is simple interest? 20. What was compound interest? 21. So what is the difference here? 1, yes. Now if I need to do like in percentage also, this is 1%, and then the amount is also 1. So think about the value 10. Now put the value 10 here. What is 10 square upon 100%? 10 square upon 100% is 1%, right? Similarly, P is 100 into 10 square upon 100 square. So what is your answer? Again 1. So exactly it is 1 rupees also and 1% also. So let's make this thing a little bit different. So think about 200 rupees and at the rate 20%, right? So in 200 rupees at the rate 20% in 2 years, what is SI? SI is nothing but 40. What is CI? If you find CI would have been like 200 into 1 plus 200 plus 20 upon 100 square minus 200. If you solve this thing, or if you do it by successive also, you can find this is like, let's say 42 years, that is like 220, 44%. So if it is 44%, then it is 88, and this is 40 into 2 simple interest, which is 80. So this is simple interest for 2 years, that is 80, and compound interest for 2 years is 88. Yes. So what is the difference? The difference is 8. So difference is how much? 8 is the difference. Now check with this formula. So 8 is the difference, and 8 out of how much? 8 out of 200 into 100, which is also same as 4%, right? So I need to see whether I am coming with 4% or 8 rupees also. Both are correct or not, right? So if I put R ka value, let's say 20. So 20 square upon 100% is nothing but 4%, right? 20 square upon 100% is nothing but 4%. But think about in the principal amount format, that is 200 into 20 square, right, upon 100 square, and you'll get directly 8 rupees also. So if you use P, then you'll get the amount. If you don't use P, then you will not get the amount. You will get directly the percentage format. So I hope you have understood this thing. This is a very important topic in this also. Now let's go for the next thing. The next thing is difference between CI and SI after 3 years. After how many years? 3 years. After 3 years. Now what is it? The answer is the difference after 3 is 3 R square upon 100 plus R cube upon 100 square percentage. Or with the format of P, I can write 3 P R square upon 100 square plus P R cube upon 100 cube. That is the answer in general. Clear? So think about in the case of 100 also. In the case of 100, in 3 years, the SI is 30 and the CI is 33.1, if you remember, right? And the rate is obviously 10%. Now think whether we get the answer or not. So put the value of 3 and the R is 10. So 10 square upon 100, 3 into 10 square upon 100 plus 10 cube upon 100 square, this much percentage, which is 3, this cancel out, that is 3, this cancel out, so you'll get 0.1. So your answer is 3.1%, and it is exactly the answer, 3.1%. So you can understand like how exactly we can solve this question, and if you use P, like P as, if you use P is 100 also, you'll get the answer 3.1 also, right? So whether you need to find in percentage, you just use the formula of R square formula. If you need to find the principal amount or the amount itself, then you need to use this formula. So that's the difference between these two formula, whether we need to get like the percentage format or in the other format. I hope you have understood this thing very clearly. The next important thing is when the compound interest is not compounded annually. Like it is not like that, like compound interest is compounded, but it's compounded half yearly, it's compounded semi, like let's say quarterly, it's compounded semi-annually, it's compounded biannually, it can be anything. It can be compounded even monthly also. In a lot of banks you can see after every month your interest has been deposited. That is like monthly calculation. In generally we have seen banks like credit your interest after 3 months, that's quarterly. So this is actually the case where we have to even tweak the compounding time, right? So let's think about a case of half yearly. Like if it is half yearly, let's say if I am saying 10% compounded half yearly, 10% compounded half yearly. Now what does it mean? It means, let's say if the amount is 100, think about it very clearly. If the amount is 100, okay, in 1 year what is the interest? In 1 year the interest is 10, yes? So in 1/2 year, what is the interest? That is 5. If 1 year the interest is 10, in half year the interest has to be 5, right? Now this 5 is basically added to here. So what is now principal now? 105. And like after half year, the principal has become 105. Clear? Because half year after half year compounded mean after half year how much interest you accrued, it is basically added to the principal amount. Now next we need to find again 100 fives. Now the principal amount is 105 and half year's interest. So which is 10 into half, like half years obviously, that is 10 upon 100 into like half years. So this is 10%, like 10% is like 10 years, so 105. So in case of that is 100 into 100, so this is 105, let's say. So if I see 100, let me just change this. So this is like 105 is this thing, right? So by the formula of PTR by 100, so it is what? In PTR by 100, this is, what is P? 105. What is T? Half. What is R? R is 10, right? Upon 100. Clear? Now what exactly we are getting? We are getting 5.25. So we are using PTR upon 100 formula, right? So we are getting 5.25. Now what is the interest? 5.25 exactly. So what is 1 year's interest? 10.25. That means 10% compounded half yearly is not exactly 10%. It's 10.25% compounded annually, right? Now we can use successive here also. If I use successive, so half year mein what is the amount or what is the percentage you are gaining? 5%. So use 5 plus 5 plus 5 into 5 upon 100. So that is 10.25. So you can use like successive also in case of this kind of question. But there is a formula also. What is the formula for half yearly, for all these things? Let me discuss the formula now. So think about the formula first. Now the formula for what? Formula for compounded interest, compounded half yearly. So we will discuss formula for compounded half yearly. We will discuss formula for compounded quarterly. We will discuss formula for compounded biannually. So three things. So for this thing, like the principal amount will become how much? The principal amount will become how much? So the principal amount Pn will become P into 1 plus R upon 100. That is R by 2 will become, because half yearly, and this will become 2n. So the year will be multiplied by 2 and the rate will be divided by 2. Like this is for half yearly. Now for quarterly. For quarterly, you have to do it for after every 3 months, like 4 times a year. So this Pn will become P into 1 plus R upon 4 upon 100 to the power 4n. Am I clear? Because why it is 4 times? That's why 4n, and if it is 4 times, the rate also divided by 4. Now think about biannually. What do you mean by biannually? Biannually means the compounding is once in 2 years. Once in 2 years. After every 2 years, it is compounded. After every 2 years, it is compounded. Now think about it, what it is happening here. In this case, the answer is Pn. Yes, Pn, obviously. Then P into 1 plus 2R upon 100 to the power n upon 2. Now this n becomes n by 2, but r becomes 2r, because we are compounding once in 2 years. So that's why it becomes n by 2. When twice in 1 year, 2n, once in 2 years, n by 2. Twice in a year, r by 2. Once in 2 years, 2r. You understand? Now let's think about monthly. Let's think about monthly. Then the formula should have been P into 1 plus r upon 12 upon 100 to the power 12n. That is for monthly. So I hope you have understood exactly how we use compound interest. This is like the basic concept of compound interest and how exactly we use compound interest, quarterly, half yearly, the difference between SICI and all of these things. And in the next video, we are going to learn a lot of questions based on this. So please watch the next video and please learning with us, and I will like to see you in the next video as well. Thank you very much. Keep watching us and keep learning. So all the best.